அந்த live on YouTube.
ஸ்டார்ட் பண்ணலாம். ஸ்டார்ட் பண்ணலாம். ஓகே.
Now I invite Professor Dr. B.
மியூசிக் ஆஃப் பண்ணுங்க. சாரி கேக்குதா?
இல்ல ஆடியோ வேற யாரும் அங்க
Very good morning to all. On this present occasion, I invite you all to join in a wonderful seminar entitled Innovation in Healthcare and the Opportunity for the Development. Civility is the armament of action, for it's through the manner of grading and showing our respectable records. We convey our warm-hearted cheer. I am immensely delighted to extend a gladsome welcome to the renowned speaker, Dr. Tirumurthy Velpandiyan, Professor in charge of the Department of Pharmacology, AIIMS, New Delhi, who is here to create gravitation impact through the webinar on innovation, healthcare, and the opportunity for the development. Our speaker is synonymous with unique distinction for his wide spectrum of knowledge, assimilating with great passion. The people who make a difference are the ones with the credential as well as concern. He himself is an example, this saying, with an inspiring profile. I am all the more glad to share with you that our dignitary, our speaker is my college mate, who value friendship and thus has readily accepted to preside over the occasion as a speaker. Once again, on behalf of management, SSM College of Pharmacy, faculty of SSM College of Pharmacy students, I welcome you, sir. It is so said, charms attract the sight, but merit wins the attention. Our SSM College of Pharmacy has always occupied an excellent standpoint in greeting scholarly professionals who care for the society. On behalf of the management, staff, and student of our SSM College of Pharmacy, I welcome you all, the student, staff, principal of various institutions to partake in the webinar and make it as a success. I I requested the L. Pondian to send a passport size photo. He to send a photo. It's like he told that it's like COVID-19. But I observed it is a scientist. The face is scientist, like Einstein. So he became an Einstein in future. I congratulate you, Dr. Vel Pandian. Once again, welcome you all for joining a wonderful seminar. I will be joined later in the vote of thanks. Thank you. Thank you, Undan.
Thank you, sir. I invite Professor Dr. Venkat Raman to introduce the speaker of today's session. Sir,
Thank
please.
You, sir. Thank you, sir. Good morning to all the participants. It is my pleasure to introduce our renowned personality, Dr. T. Velpandian. He is a professor of ocular pharmacology who is currently working on ocular pharmacokinetics, and his lab covers all the areas of ocular pharmacology. Coming to funding, he has obtained funding from DST, DPT, ICMR. Like that, he has obtained many funding agencies, and his lab has received level 1 grant in DST, and based on that they have purchased LCMS instrument. And coming to awards, he has got many awards. I will mention one, Ames Excellency Research Award. That is a very prestigious award he has got, and like that there are many awards he has received. And another honor to him is he is a visiting professor in Harvard University, USA, and BPKIHS in Nepal. So in that also he is a visiting professor. And regarding the fellowship, he has obtained many fellowship like CSIR, ISER, like that many fellowships he has received. Coming to patent, he has patented more than 10. And coming to paper, he has more than 100 publications and all indexed journals, and all are original articles published by him. So dear participants, I'd like to join to welcome Dr. T. Velpandian on this occasion. Sir, please proceed, sir. Sir, proceed, sir, please, sir. Yes, sir. Speak at the hand over Manila.
Sir, hand over to speaker, sir.
Yes.
Hello, Vaijayanti madam. Please stop the slides.
Mic on பண்ணு. Shall we start? Sir, mic on.
Sir,
Suresh?
speaker, sir.
Yeah. Namaskar. I hope I am audible to everybody. So thank you for inviting me to give this lecture on innovation in healthcare. Well, I must thank Chairman Ilavarazan, Professor Sangameswaran, Professor Venkatraman, and all the coordinators made it possible, right? So I'm very happy to give this lecture today. And it's much more important in this context when we have COVID around. So the opportunities for the innovation is very high. Therefore, this lecture is very prompt. I thought that this is much more important right now to discuss about it among people, especially among the technocrats, the students, those who are working in pharmaceutical sciences are technocrats, and this is a good opportunity for them. So innovation in healthcare, opportunities and their development. See, today, Government of India is doing a lot of things to promote this. And funding, there is no problem that you knock the door of anybody, right? From DST, DVT, BIRAC, and there's so many other funding agencies. They're all ready to sponsor your research. So in this contest, I just try to cover up the aspects of innovation. What is this all about? What things we should do? What we should not do? How do we go about it? I thought that would be a much more important understanding about it. So sometimes what happens, we observe something, but we don't understand the value of it. Sometimes we feel that this is something that, this is a grandma's word, which may not be having any use. But you will not believe, now we understand that it's not that true. We are not able to understand what has been said. For example, let me just start my lecture with a small introduction about it. I think all of you must be knowing about something which is very unique. In a very dry climate, right? All of a sudden in the night, in the summer, when you see the moon with halos, I think all of you understand this halos. I think in Tamil they call something like a kotai, right? So it's like a ring around the moon. Immediately, farmers will understand that they are going to get rain in the downtime. See how they understood this, that what is something which is relevant with this halos, what we see in the moon, and how is it going to bring rain? And today, we were not knowing. When I was a kid, when my father used to tell that, we used to get, to see this halos and we are going to get rain. And I was not able to understand that, how this is, what formation it happens, because it's not explained even in the science textbooks. It took such a long time for me to understand about what is it all about. So today we understand that that is the first stage of cloud formation. The crystals of ice which are getting formed, it's called, we call it as cirrostratus clouds. That is the ice crystals which are getting formed at that such height, and which causes the refraction of light, which is refracted into it. And what you see is there's a round ring around that, what we call as halo. And this is going to say about what is more interesting than seeing this halo for a farmer who is looking forward for rain in another 2 months. So what we don't know is something that we call this is something that a belief which is this is a wrong belief, or it is a a old belief or grandma's belief. That's not true, because we could not understand what it was about. But it's true now, we know, yeah, it is having something to do. So why am I trying to tell you is that what you see sometime, but that is an opportunity. And what you're failing to understand is something that which you really missed it to achieve it. Similarly, there is something called chaos theory. This theory is very famous, right? I mean, when you just look into it, you'll be able to understand this chaos theory. I mean, it has been told that sometimes, I mean, that it has been sold something as small as the flutter of a butterfly. Can it produce typhoon somewhere in the world? Basically, a butterfly is fluttering its wings. Can it cause a typhoon, or can it cause a sort of a storm? Can it cause a heavy wind blow? So this, we always see that that's impossible. There is no link between this and that. A small butterfly is fluttering. How can it produce anything? So this is what we always talk about. But when you just see, this is classically called as chaos theory. Oh, I just observed something and something big has happened. What is the link between these two? I must tell you, in this case, some small observation, right? So this is something which is very interesting. This when in common it is, we call peacock dances, or a croak of a toad, or a frog can bring rain. No, you say immediately bullshit. That how can you expect that a dance of a peacock, or the peacock's the sounds of the peacock, or it's a croak of a toad can bring rain? I know you were not able to understand what exactly is happening. But now you'll be surprised. Just see that there's a barometer is in between in this. This barometer shows when the air pressure drops, I mean around 990, then this is going to cause rain. When the pressure goes up, see that you won't be able to get you will be having a clear sky. So the simple astronomical observation of the observation is being converted into some terms of air pressure. Now, these animals like peacocks, or it could be toad, they are having a mechanism to understand the air pressure. For example, that you are traveling to a hilly place or a mountain place. When you are just traveling, all of a sudden you see that your eardrum stops hearing, or you just starts muting. So that shows that the eardrums are sensing the pressure outside. That shows now the peacock. Why the peacock supposed to anticipate rain? See, just look into the peacock. The peacock or pigeons or birds known as fowl, the members of the apiacean family, they prefer a rich, protein-rich food for insects or millipede or snake, anything which comes in a small thing for the young ones. So they have a 28 days nesting. So the moment they see that there is a drop in air pressure and it is about to rain, they just look for it they give a mating call. Now anything happens, if the mating happens there, then the pigeons or the young ones, when they are coming out or hatching out, in that case they will be able to get enough amount of food for them to eat and for their survival. This is something that everything is coordinated in a way. And now, considering all these things, suppose about today we have a very advanced weather forecasting facility. You will be able to understand about, when you are expecting a rain at 9 o'clock or 10 o'clock or 2 o'clock or 6 o'clock. And it is possible by simply just looking into the mobile phone or AccuCheck weather, or seeing in a TV or in the news. But in reality, this is possible by a very, very rain predicting, a perfect algorithm. This algorithm uses all these aspects about the surface temperature, about the air drop, about the movement of clouds, and the speed of wind from a particular direction. All are calculated together. You will not believe, about 10 years or 15 years back, BBC used to use 92 parameter algorithm to predict rain at a certain place. Therefore, what is more important is that something we know, something is happening, the link between these two. Sometimes chaos theories do come true. So we cannot just, you say that these are all these beliefs are very, is not very, not scientific. You never say like that. When you go more inside, you understand about this kind of ideology. So what is more important is you should always learn to look beyond. So what you see outside is something different. When you start thinking is something different, and you're trying to innovate something. There is a fundamental difference between innovation and invention. Well, when you see what is something a great difference in that. So innovation is always having an incremental value of the knowledge what has been known. And all it's something like not necessary that the moment you talk about innovation, don't think like that. Okay, I have to be an Einstein or I have to be a Thomas Alva Edison. It's not true. Innovation is always an incremental value. Whenever there is an opportunity, there is a problem. Whenever you see a problem, an opportunist see a good opportunity for innovation in that. That is why he is an opportunist. He see a problem and uses opportunity to create something to solve the problem that becomes his product. Now, there are so many things. See, in this lecture, I wanted to emphasize on a few things. So the most importantly, what I wanted to say is that, see, that many of the M.Pharm students, I think some of you must be listening, are those who are doing master's degree or those who are doing PhD, they're all doing project work, they are doing thesis work. But very casually, they go for publication of it without understanding the dimension of their invention. There is some step in between it that is called intellectual property right. So I must request that the colleges, whomever is involved in research type of projects, they should allow the students they should encourage the students to go for filing intellectual property right before they're going for publication. And it is very important, today you have a NIRF rating, rating scale, in which if you have the number of patents you have, number of commercialization you have, you will get the ranking going up and on the scale. Therefore, today's mantra is innovation, and innovation as a top priority. Once we try to do, not necessary that I'm going to look for it for a job all the time. Even the companies, those who are taking you, they look for it for a person can innovate. What am I going to achieve out of it? Because what you are expected to do, somebody else can also do. But innovation is something that which is not expected from everybody. So whenever you look beyond, somebody makes it happen and somebody wonder how it has happened. This is the difference between these two. So when you look beyond, if an innovation is unidentified, one is blind to see the opportunity. This is how we try to look into it. So just see this is a small cartoon. Somebody is using an umbrella to prevent himself from the rain, but the other person is using umbrella as a water reservoir from the rain to collect the water. So the difference is here the same, that you try to reverse the umbrella in a different direction. So this is how the innovation is explained from a normal view and the innovator's view. There are different ways. There are different ways that we try to see innovation. One is inductive reasoning or deductive reasoning. There's two ways we try to divide it. Inductive reasoning is that you have an observation or you're trying to have an observation, and the observation from there that you're trying to generalize few things, and you try to figure out a paradigm, and from the paradigm you are trying to go ahead or trying to create some sort of a theory, and you try to go for predicting and doing by the experiments or trying to develop this thing. But the other way around is theory. Like, I have been taught a theory. Okay, now we know that cyclooxygenase inhibitors can be used for as an anti-inflammatory drug. Therefore, you try to look for drugs which can bind to cyclooxygenase or which can inhibit cyclooxygenase. That is some sort of a theory. You know very well that cyclooxygenase, you do not to prove cyclooxygenase involved in the inflammation or prostaglandins are involved. You try to stop the production of prostaglandins by blocking cyclooxygenase by different compounds. This is something a theory, and you try to do an experiment. From the experiment, you come out with the conclusion that yes, I proved the hypothesis and this is going to do it. The other way around is you observe something and you try to, from the observation, you try to generalize and try to take the information and try to develop things, and you try to fit where it is required. I think in the next few slides, you'll be able to understand a little more about it. I always try to show this, C.V. Raman's picture. That is one of the beautiful things he said is that, which I always get attracted, that is the real fundamental success is always due to those who have ignored the boundaries and treated science as a whole. Don't tell me that, right? Students always tell me that I'm a pharmaceutics person, I'm a pharmacognosy person, I'm a pharmacology person. But together with this kind of differentiations and divisions, you will not be able to do good science. The best way is that you treat science as a whole. You have a problem and you try to find out a way in any branch of science to deal the problem, and that is where you try to achieve it. So this is what the C.V. Raman's word. See that he is a physicist. You know very well there is a physicist he was working on. You know about scattering, Raman scattering, Raman effort, and everything like that. Just behind him in this picture, if you see on the blackboard, a physicist is having a diagram of a biology that is new, that is a retina, a retinal structure. So you see that a physicist is exploring biology. So it's nothing like there is no clear-cut boundary that you can only do this, you can't only do that. Science in which all of us are together to achieve something. But one thing, there is another phase I have here. This is a common man. This common man is asking something from you. You had education. You did a research. You published papers in high impact journals, but what impact it has made on my life? So I have contributed to your education. Now don't ask me that how he has contributed. Yes, he has contributed. A person, everybody in India contributes directly or indirectly towards all the social services government is doing. If you are getting an education from a school, or if you are getting education from a college, if you are getting a fellowship, if you are getting an award, everything comes from a public fund. What is public fund? Honest taxpayers' money. It's maybe 20% of people in India are paying direct taxes from their salary. Rest of them are paying indirect salary. Suppose if you are buying a loaf of bread, or if you are buying something from a market through GST, a common man contributes towards a common fund, and that fund is given to you for your contribution. Therefore, you should always think about a common person, not necessarily that there is a involvement of money, but when you are trying to do something on innovation, the whole scenario in the world, the progress of India goes up, the society goes up. Today you see China, for each and everything before COVID, during the time of COVID, we were just wondering. We were not having anything of Indian origin, except even in the pharma industry, many of these raw materials has to be imported from China. And China has such a big influence on Indian market, where we were not even having a simple things in India to make our own sustained life or our contribution. A country like China, we are depending on country like China for each and everything. This is a very shameful thing for us. Of course, India has reached a very good self-sustenance in case of a pharma industry as well as software. In both the cases, I always say that, right? India never done anything on a new language in computer sciences, or never it invented a hardware. It only worked on whomever has done something. They only did a little bit of innovation to make software. So today we are software giants. Similarly, we did the same little bit of innovation, and that pharma companies never went on individual discovery. There been hardly anything we call it as individual discovery in which India progressed in pharma industry. In formulation, we revolutionized it. We reduced the cost of drugs and we started selling outside. But that is not a way how we are going to sustain over the period of time, because the other third world countries like Indonesia, you will say Cambodia, Indonesia, all these people have started now. Their pharma industry is giving drugs cheaper than India. So cheaper version is not something that's going to solve the problem unless otherwise you get into innovation. A simple thing which I just attracted me was, when I'm from a farmer's family, therefore of course my father is to get up at morning 2 o'clock, and he won't even sleep. So the morning he's supposed to go at 2 o'clock and to switch on the electricity. To switch on the water pump, so that he can water the paddy field. So there was an unmet need. I always used to think, there should be a way that I should sit at my home. I just switch it on a walkie-talkie that it could switch on. But when the innovation came up from somebody, this is something which is very, very interesting. See that a simple mobile phone is now somebody made it actually. Now today this is commercially available. This small instrument is connected to the mains of the water pump. The farmer knows that 2 o'clock he will get electricity. So what all he has to do is that he will suggest to give a call to that number from his mobile. The mobile connects to the tower connects to the small system which is attached to electricity. The water starts pumping. At the same time, at 6 o'clock, again, you can say you switch it off. Again, you use another call or send a small short message, and again, it switches off. What you see from this is a reality. What you see is creativity plus work is innovation. Work everybody does, but there is some amount of creativity is required to convert your work into innovation. But there is the unmet need. First of all, what I see is that this, when I was a kid, I know that it's an unmet need. But unmet need gives an opportunity to address the problem, so to make it available for that person, a farmer. Therefore, as that is pushing me to choose the options through which I can, whether I push it or pull it. Suppose if I develop a product, I try to find out a user for it and I push it into the market. This is something like I'm pushing it. A scientist who designs something, you look forward for somebody to take it up, and you look forward for a market for it. Sometimes the market is already available, only you need to understand the demand. Therefore, the demand, unmet need, and or either push or pull, or you under scientist who is having the knowledge. So in both the cases, it becomes very synergistic to bring an innovation into market. The opportunities are pretty plenty. Let me just show you something very interesting. So sometimes in the discoveries goes differently. So let me just tell you something which is very, very extraordinary. I thought I should just share it with you. So I think all of you must have seen this small instrument. I mean, when we were a kid, we used to play with this. I hope that people at different parts of India, we know that very well. And it's really a small sort of cap in which you put the two twines and you try to cap it. And I used to make, when I was a kid, I used to make it, and we used to pull it. And I was trying to ask everybody about what do you call it as locally, where I could not remember. But all of us, we have done it. And in fact, some confectionaries came with a small toffee which can be rolled like this. I hope all of you remember this. So this is something which is very, very interesting about to understand about it. Share computer sound. I think I'm just sharing the computer sound. So this is a way that we used to play around when we were a kid. So whenever I used to see this kind of, we call it as a yo-yo. But yo-yo is a Chinese one, but we're not very much know about it. But, so when I seen this, I was fascinated. But when the publication came up about this, there was a guy from Muthu Prakash. He was from Chennai, and he went to Stanford, and he converted this into a spinning toy, and he reinvented it as a local, low cost or low tech centrifuge, where it can be used in the places where there is no possibility of electricity. Just check this innovation. This is very interesting.
From a technical spec point of view, we can match centrifuges that cost all the way from $1,000 to $5,000. But this is a tool that requires no electricity, no infrastructure. You can carry them around in your pockets for a price point of 20 cents.
We call it a paperfuge. It's essentially a piece of paper, and we put in small holders for capillaries that we can fill with blood. And we have standard string, and we take two pieces of either PVC pipe or wooden handles, and then you just pull on it gently. As you spin, the disc is rotating back and forth. It's rotating in an oscillatory fashion, and there's a moment when the disc is stationary, and then it starts to unwind and go in the other direction as you apply a force.
With this set of principles, we're able to essentially make a centrifuge that spins all the way to 120,000 RPM and 30,000 G. Centrifuge that spins all the way to 120,000 RPM and 30,000 G forces. In the lab, we can separate and pull out malaria parasites from blood. We can separate filaria, African sleeping sickness, separate blood plasma. It is an ultra low cost
So this is
centrifuge that's built out of principles of a very old toy, the Whirligig.
This is a toy that I used to play with as a kid. the puzzle was that I didn't know how fast this would spin. And so I got intrigued and I set this up on a high-speed camera. And I couldn't believe my eyes. This thing, when you hear the noise, is actually going at 10 to 15,000 RPM. To me, that seemed like what we wanted to actually make a centrifuge.
Before us, nobody had actually understood how this toy works. So we spent a significant portion of this time truly understanding the mathematical phase space for how you can convert linear motion into rotational motion. There's some beautiful mathematics hidden inside this object. There is a value in this whimsical nature of searching for solutions because it really forces us outside our own sets of constraints of what a product should actually look like.
The centrifuge is the workhorse of any laboratory, from diagnostics to biology. And if you build a very essential, a key instrument, then you open up to a whole different variety of applications.
We just got back from Madagascar. We took the tool out to the field to work with health workers, and we're starting a clinical validation trial on a larger scale to share it with the community and the healthcare service providers, get the feedback. So it's a very iterative cycle. There is of the order of 1 billion people around the world that live with absolutely no infrastructure, no roads, no electricity. So for us, the inspiration is to make the simplest possible tools that do the job well, such that you can get them distributed around the world.
So it's a very interesting thing that to know that somebody has picked up from this when we were kids, we used to use this, and he went outside to Stanford University. You need a Stanford University to convert this into a centrifuge, and it is of great use. Similarly, you see that this is one of the a good finding. It got an award. So this, what you call as what is that? Something like a incubator, where your newborn babies they are kept in underweight babies, or they required incubator facility for a baby which cannot spontaneously breathe, or it's underdeveloped baby. So for these kind of newborns, we use this kind of incubator. Can you believe that this incubator has been made somewhere in Africa by a used car? A used car spares have been used. A used car is of no use, that you have to just throw into dustbin as 18 kgs. But somebody converted this into an incubator. There is a low-cost incubator, and now this is something which is very innovative, and it is available for them. Therefore, that is a way that you try to look for innovation in something. So this is something which I was discussing with you about it. That is an extrapolation. Similarly, from a logical findings, like what you see, what I see, and what exactly an innovator see, there's a difference in which it. So let me just show you something on this part about it. Well, about in this case, 1 minute, yes, 1 minute, yes. So that the relationship is all of us, this is again a beautiful clipping. I think you should be happy to see this. Now, all of us are afraid of
To abstract venom with our venomous snakes, we literally milk them onto a venom vial. It just looks very similar to a shot glass. As the fangs pierce through the layer of plastic, the venom dribbles down the glass, and then we draw that up, and that's the product we use to make antivenom. Tiger snake venom, that amount there is enough to kill about 30 adults. What we're going to do now is we're going to put this tiger snake venom, the raw venom, into some human blood and see what happens. As we start to inject this venom into the blood, it'll start to change colour, and then it'll start to congeal inside of the glass, and to the point where you can literally tip it upside down and just a big clump of blood will come out. This is exactly what happens inside of the human body if you're envenomated by a tiger snake, and there's many other species too that can cause this. With Australian snakes, they generally attack your blood system and your central nervous system.
So this is what we are afraid of all the time, but snake bites are very rampant, and we are afraid of snakes. And mostly what we do when we find a snake is that we try to kill the snake. We never bother to know that how it kills anybody, and what is there in that venom. How can we use that venom? Can you believe that this venom, from there they got this hemocoagulase the enzyme which causes, which clots it. Therefore, people, those who are suffering from clotting disorders, so the hemocoagulase injection is used and it is isolated from this venom of Botrox and Atrox. From this venom of the snake, it has been isolated, and we know that it has a thromboplastin-like and a thrombin-like activity. That one activates factor X in the coagulation cascade, and it leads to a coagulation of fibrinogen. So something that what we failed to understand in the snake, and which has been converted into a product, and it is of used in the masses. Similarly, we know very well that today I need not to teach you about what are ACE inhibitors. And today we talk too much about ACE inhibitors, about the ACE2, where the corona binds to ACE2 binding site. So we know that the drugs like captopril, enalapril, lisinopril, all these pills which they bind to it. But if you go back 30 years, there is a Brazilian arrowhead viper, that Bothros jararaca. This is a venom contain the peptide inhibitors that causes hypotension. When the snake bites, people get hypotension. This hypotension, then they start understanding that what is that peptide which causes hypotension. From there, they came to know that it's capable of blocking angiotensin 2. This is something which is happening. You know that the action is hypotension. So you converted that into it. Now you know that what is the mechanism of that hypotension. It binds to ACE. Then it was resolved by extra diffraction studies about how it is making complex with the angiotensin converting enzyme. From there, they created these inhibitors or ACE inhibitors, what we safely use it today in modern day, this one about it. Next thing is about bat medicine. Today we are afraid of bats because after the corona, now we are afraid of bats. They say, oh, bat is the, somewhere in China, that a bat is the one, somebody taken bat, eaten the bat, from the virus transferred from the lungs of the bats to human. This is what we talk about bat. But do you know that how much important bat is in the discovery? Just see this video clip. This is very important.
Here are some happy vampire bats. What's causing all this giddiness? A great big fat meal has arrived. You can practically hear these bats going, oh boy, oh boy. Better yet, the victim is asleep. This is going to be like, well, taking blood from a sleeping pig. The bats have heat sensors in their noses. This thermal process lets us see what the bat sees. The bat wants to feed where the pig's skin glows white hot. Let the dining commence. Like two wildcatters fighting over a fresh oil strike, these bats battle over a particularly rich feeding spot. 4 vampire bats, 1 sleeping pig.
With the sharpest teeth in the animal kingdom, the vampire bat gently shears away the hairs of its victim and makes a small incision in the skin. The tongue slips along the funnel-shaped bottom lip, lapping up the blood. Fine microscopic grooves line the soft tissues in the mouth. The blood flows up these narrow tubes and pours into the throat of the bat. Thanks to a local anesthetic in the bat's spit, the victim doesn't feel a thing. And a blood thinner keeps the life liquid flowing.
This is what more interesting is all about that. So the vampire bats have 2 things in this. Number one is, this is the vampire bats in their saliva. They have a local anesthetic. Therefore, the victim doesn't know that somebody is sucking my blood. Another thing is that it has some anticoagulant also. And you will not believe, from them they are isolated from the saliva of this Desmodus rodentalis that is known to affect the clotting mechanism. That means it can even bust the clot. That in 1990, a recombinant D. rodentalis salivary plasminogen activator alpha 1 has been investigated. Today we talk about the clot busters, what we call for stroke, all of them working on the similar lines. So the moment if somebody is down with stroke, what we try to do is there is a clot in their brain, and we try to give a clot busters like urokinase, streptokinase, something like which could dissolve the clot so that the blood supply can be restored. So this is something that desmotilase Altiplase, I think all of you know about. It's available in the market. Desmotilase was which came into the market based upon this identification. They found it, and it is called a desmotilase because it is obtained from Desmodus rodentus. So this is, it went for acute ischemic stroke trial, and the normal tissue plasminogen activator works for 3 to 6 hours, but this has more effect up to 9 hours. So for example, that if we just give a single shot injection for 9 hours, that person who is undergone stroke will not get again the propensity to get another clot. So this is a complete list of half-life of all of them, all of urokinase, Altiplase, streptokinase, everything, in which desmotilase is coming out to be 138 minutes as a half-life, and the fibrin selectivity is pretty high. Therefore, this could be a good alternative. So look, these are all the places, we know very well that we are isolated. I have enough evidences, and I don't think I need to tell you about this. In plants, you say a lot of evidences. But what happens is that you go for only extract of it, and you submit your thesis or complete your research, and you submit for publication, you forget it. But reality is that you have to identify the active component in that, and you isolate it. Try to do a little more research. I mean, why only one thesis? Take one thesis, divide it into 4 people, and everybody will work on separate aspect of it, and together they make a good paper. By the way, one can do so much of work, right? I mean, you'll be able to get a patent for it. You'll be able to read something. So another one important thing is about anticoagulant from leech. So some of you must have had an experience with a leech. The leech, when it bites you, then you will never be able to know about what exactly the leech is doing. I mean, whether it is sucking my blood or not, because again, it is having some mechanisms. Anything, see, leech, immediately you put a little bit of salt, or you put tobacco powder or something like that to paralyze it, or try to, you try to irritate it to kill it off. But the reality it is that it's having a very sophisticated blood sucker, and the blood sucker, it is also having an anticoagulant. So when the leech is sucking the blood blood clots, the leech will die. It won't get the blood. This clotting mechanism of your body need to be switched off. You will not believe that is how most of the organisms, when they try to attack human, they do this. Even so, from this they isolated something called hirudin. Is a natural thrombin inhibitor from blood-sucking leeches. So this is the blood-sucking leeches are called Hirudo medicinalis. So from there they isolated something called hirudin, and during the natural coagulation, they are natural coagulation inhibitors. Then semi-synthetic derivatives came up. So now this is available in the market. Now we say somebody launched something that it is the real the one which is derived from the leeches is not derivated, or it is not modified. So that is more expensive because it is pretty natural. People feel that if leeches have been attacking human for a long time, therefore, but they don't cause any other problem to human. Therefore, that is much better as compared to something which is man-made, newly made, which can have any problem. So this is right now approved for deep vein thrombosis or superficial varicose vein, etc. This has been used. Similarly, can you believe that a diabetic drug has been isolated from lizard? Sorry. So this is something called a glare monster. Just see this video.
The Gila monster is one of the only 2 venomous lizards found in North America, and the only venomous lizard native to the U.S. They're mainly found in Arizona, Nevada, Utah, and some parts of California. They're 2 feet long and generate a venom in their salivary glands that is among the most potent toxins you'll find in the U.S. Nature, the Gila monster is fairly sluggish. It also spends 90% of its time underground, only coming out a handful of times a year to hunt for bird or reptile eggs. Gila monsters don't have fangs or any other means of injecting their venom, so instead they propel the venom onto their teeth and chew the poison into you. And to make matters worse, the venom is generated in their lower jaw, so they have a tendency to latch onto their victims and spin over to help the venom flow. Gila monster's venom is potent, but it releases a very small amount of the stuff at a time, and only uses it as a defense mechanism. So it's more interested in excruciating pain, edema, which is also known as dropsy, but pretty much just means swelling, a drop in blood pressure, and not death. Gila monsters are rumored to have toxic breath, to be able to jump several feet in the air, to spit poison, and to piss and and poop out of their own mouth.
Very interesting that about the Glea monster. But the Glea monster, from there, they identify something very interesting. The lizard is containing something which is a endocrine function is having something called extendin. So basically, what it does, it has something in a hormone itself. So for months together, it eats only 4 times in a year. So after that, it just keep quiet and it sits inside the butthole, and it shuts down the pancreas and by stimulating something in its blood. So what we know now is it's an endocrine function of it is called extendin. And if it is not getting it, it's stimulated by using extendin when it gets its meal. Otherwise, it just keep quiet. So there are a number of bioactive principles in this to doing different activity. But what they found is that extendin is a potent agonist for mammalian GLP-1 receptors. The GLP-1 receptor, what it does, it stimulates insulin release. So it stimulates the glucagon-like peptide 1. We know very well it stimulates insulin, and therefore now it's a good one for diabetic patients. And they found that this naturally stimulates insulin through a different pathway, not through the direct potassium channels through which classical drug act. So there's another novel mechanism of action they found from this extendin, and it stimulates it. How it works, right? When a food goes to the stomach, from the stomach, it also stimulates the insulin release or amylin co-release. It's automatically that in the cephalic phase. If we just go detail into the sugar absorption, you understand that how things are getting released. In the whole thing, that what it does is GLP. GLP is secreted here, which stops the glucagon release, and it promotes insulin secretion in the beta cells. So, and also most importantly, it suppresses appetite. It suppresses appetite. So the moment the Glea monster is eaten something, that means the insulin secretion is good, and the glucagon is no more glucagon. So it just every insulin is secreted, whatever the glucose it is absorbed, all gone through the cells, and it suppresses appetite further. So it goes for rest for next 4 months. It is on fasting. So now it has become a very good agent for diabetes. And this is the exenatide and extendin. From there, we have, and liraglutide is a new one. So in which GLP is an incretin, thus its ability to decrease blood sugar levels in a glucose-dependent manner by enhancing the secretion of insulin. Therefore, now this is all coming into picture now. So the GLP-1, this is how it acts on, see that exenatide. So this is how it the mechanism of it. So this GLP-1 agonist, they are incretin mimetics, approved by US FDA in April 2005. Actually, I just told you that these drugs like sitagliptin and vidalagliptin, what they do is they just try to block the dipeptidyl peptidase, which act on GLP-1. There is a natural endocrine function of ours is GLP-1, but exenatide will not be cleaved by dipeptidyl peptidase. Therefore, sitagliptin or vidalagliptin, what they do, they block only dipeptidyl peptidase. Therefore, that's how they make GLP available for more amount of time. Instead, you give exenatide directly, that it mimics like GLP-1, having a longer activity, not getting metabolized by DPP-4. Therefore, you see that there's an opportunity, right? So this is a drug which has been now marketed as a subcutaneous injection. In 2005, it came to TDDM. Well, this is something which is very interesting. It was something in last year, I believe so. So that time that this paper came in Nature, there is a new antibiotic has been found in the nose of human. So far, you don't see human is having antibiotic. You have seen only the microbes having antibiotic. You don't see human is having antibiotic. So, we immediately took this serious note of it, and we were all discussing in the laboratory. And, some of my students were, were very much interested. They were telling me, sir, if it is found in nose, so I forgot to tell you, in nose, lignin is the name of this antibiotic. This antibiotic is not produced by our body, but our body harbors something called as Staphylococcus ligninensis. Is a microbe, is the bacteria in the nose, and that bacteria produces lignin. Understand? There is a synergistic relationship between us and the bacteria, and the bacteria produces glutenin, and that stops the growth of microbes inside the mucosal area. So whenever there is a mucosal surface coming in contact with air, there is always a protectant. So immediately my students said that, sir, let's check it up in the eye, because you know very well that nose is connected to the eye to the nasolacrimal duct. So my students said that we wanted to study. Well, we took this option. So immediately we took the volunteers and we took the tear film and we got ahead with analysis. You know, you will not believe, this is so beautiful. You know, actually I'll show you the data. Basically, these kind of microorganisms are many places. They are in the skin. They are enough amount in the gastrointestinal tract, like you know very well about probiotics. I need not explain too much. In urogenital tract and in mouth, pharynx and respiratory system, wherever there is a contact happens between the mucosal surface of a body with the environment, there is always a microbe, there is always a defensive system, and they protect us. When our experiments, when we did it, you see that this is a structure of this is called a lignin. Immediately my students picked it up and they tuned it in the mass spectrometry. See what you are getting it here. So we were so surprised. We were having lignin in that tear film. So now we extended our work. Most probably we'll be sending the paper soon about that. We found something which is there in the eye, and you know it's having a very peculiar factor. This is thiazolidone containing cyclic peptide. See, look, cyclic peptides are very stable, not like our linear peptides. Like you know very well about cyclosporin structure. Again, it is a cyclic peptide. Cyclic peptides are very stable, and it is having thiazolidine containing ring, and thereby it behaves like that. So we were immediately, you know, you will not believe the guy who discovered this as patented before he put it into the publication. This is the shocking news. Therefore, you can't say that, okay, I'm going to do the same thing in my lab. I'm going to say, but well, what we understood is that we found in the tears. That is something which is very interesting. Now we understand. Now eye, in the surface of the mucosal surface of the eye, is protected because also due to it's not that you know we are only depending upon lactoferrin in the eye or lysozymes, or we also have this glutenin in the microflora of the eye is having this kind of antibiotics capable of preventing that. So now next one, I quickly go to the social system. How can a innovation be found in the social system? See, now this is actually, you know, I'm trying to cover as much as possible in where our contribution is also there in something which we could figure it out. That makes more sense. See, this is what something, you know, in Assam, we found an NGO working in Assam contacted us. They have something very, very unique. And this tribes in that area, they weave a silk called Assam silk, which is also called as a Ahimsa silk. See that, you know, all of you know about it. How do we get silk from the silkworm is that you kill the silkworm and you take the pupa and remove the silk threads and you spin it and you take it out. This is what we do it. But these guys in Assam, they mastered a technique that they don't kill the silkworm. They have a technique that they remove it, they allow the butterfly to hatch from that. From there, the metamorphosis of the butterfly takes place there. The broken pupa, from there they start weaving this. And the silk has a very big, very good texture, and it can get it in different colors also. So, but these guys, these silk is highly preferred in the countries like where Buddhist countries, or many people prefer it because they don't want to kill a silkworm to produce silk that you can wear it off. You can wear it. So, you know, it always takes, you know, you need a 3 lakh silkworm to produce one sari or dhoti. But here, without killing it, if you make something, you feel so happy that you have not killed somebody, you have not killed an organism to wear a sari, which you call it as a silk sari. This is what the feeling people get it. So this Assam silk weavers are a very, very unique culture there. So when the NGO contacted us, we went on understanding. One of the students started working over there. She brought the thing inside and we were very fascinated. You will not believe, you know, anytime, whenever you try to do it, you know, there is such a complicated network. There is something, a tribe which has an idea. They are doing it. There is something called input supplier, where the backward linkage or forward linkage. The forward linkage for the weavers is that where they are going to sell it, and the backward linkage is that who are all going to produce the silk. There is some sort of an ecosystem is persisting, and somebody was highly interested in developing the tribes for their betterment and to come out with some other value added addition, some value addition in the process what they're doing it. Therefore, we try to understand how they try to dye. Dyeing a cloth, all of you, what you do is that if you want to dye any cloth, what do? You get a powder, that color dye you get from the market, you just put it in a hot water, you try to soak that, you heat it, soak the cloth, and you color it. But what we observed here is something different. These guys, how they make colors? By using onion peel. Can you understand onion could produce colors? So what you see here is this lady here on the left-hand side corner. See that they are now trying to take out the onion peels. Now she is boiling the onion peels. She is trying to take out, she filtered it, and she tried to take out this one, and she has taken out the extract, now soaked the silk cloth inside, and for some time, and after that the silk is colored, and they take it out and they dry it out. So this is something which, about a woman considered what we call this as mekhla chadar. It is very typical for Assam, and we were highly interested. Therefore, we thought that why don't we do a value addition, trying to make some shades of these colors. So we went on understanding what are the composition of this extract of onion peel. You will not believe the types of colors what they could produce. They have a typical problem. There are many things they do it. So we had a typical problem of understanding about this. So when we subjected this for mass spectrometry as well as for PD analysis, we found different colors contributing to different peaks. Like for example, we found quercetin, and the very silk extract, we took it and we tried to do a mass spectrometry. We found that onion peel containing several components. Some of them are cyanidin 3 glycoside and cyanidin 3,6 malonyl glycoside and delphinidin 3 glycoside, and there are some more things which were present over there. With this, we were trying to create the color of choice by using all different colors. So now we did a little value addition to these stripes by making shades of colors so that they will be able to get a better market for that. And moreover, the NGO was very happy to file a GI. That is one type of a patent for them, that nobody will be able to use this code mekhla chadar of what do you call ahimsa silk. Nobody else will be able to make it. Sometimes it is what we call geographical indication in case of intellectual property right, and it is very much essential for the tribe to survive. So some amount of innovation what we could help the tribe is enough for them to sustain their life much more a better way. So not only we achieve benefit through our innovation, so society also get the benefit because of this. So this now we are trying to, after the intervention, that we are trying to create more amount of revenue for them so that they continue their tradition over the period of time, not to buy cheapest Chinese silk and just to throw these people into trouble or throw the people into poverty. So we try to upgrade it everywhere wherever knowledge could go off. So this is something which I took you about, about the drugs, about what you feel you try to convert it. Let me tell you something which is very interesting, and today's point of view, what you've seen it. It's not only in terms of something on drug or something on material, something on opportunity. You try to develop anything through intellectual property right, you can cover anything. For example, today you're trying to design something which is capable of handling a specific aspect by using a software. How do we go with that? In all these things, you have to take a help of intellectual property rights. So if I start talking on intellectual property right, that goes as completely one of our seminar that I won't be able to complete it. Let me just confine myself to innovations. So sometime later, if possible, I will try to cover something about intellectual property right, how we try to protect all these inventions. So for example, that whenever we open this Adobe Photoshop, one of the most powerful software, I always see the name of an Indian on the name which is running over. Here you see, I think all of you could see here, Adobe Photoshop, Sitaraman Narayanan. So whenever I see, I always feel happy. But just below see, US patent 5146346, patent pending between this and this year for this version. And after that, they must have got another version, another patent, another version, another patent, what we call as an incremental patent. So continuously this innovation is blocked. But who are all holding the patent? These people are holding the patent because they made this provision possible, and through which they do it. Today, I know many professors in foreign universities, their salary is less, but through intellectual property right, the amount of money they earn is multiple time of their salary. So today, you know, what a problem which I always see here in India is that you publish every damn thing. That too today, after we start getting the online journals, especially the journals where predatory journals, we pay 800 rupees, get your article published. Tomorrow it will be published. Day after tomorrow. I am telling you, none of these articles are going to help you at any cost. And you only expose your innovation to public, that to open access. It is considered as an advertisement. And you know, the knowledge comes to public domain. Once the knowledge is public, come to public mind, you killed an innovation. You killed. It's not that, you know, you're doing innovation for the sake of, oh, I do innovation, I'm going to help society. Society will never take anything. If somebody is going to invest money on developing a product, he will expect you to give him the intellectual property right. So intellectual property right makes a manufacturer to work upon this more, to invest money more. If something is of his own, then only somebody will put money on the business to develop it. Today, to make everything, you need money to develop something. Therefore, all these softwares, you see that sometimes I see the softwares being sold by big companies. They say, you know, it could be, I don't want to name them. There are many companies, they sell the softwares for docking, and they do it for for small experiments of QSR, etc. But you just go and understand the QSR, which has been with the underlying algorithm which is involved in that. You know, nobody is questioning that. Can it be able to predict really what exactly I look for it for? The predictability of all this softwares are very poor because it is not been validated anywhere. But they sell it for such a high cost because it's like for me, it's just like looks like a Tom and Jerry show. But what you're supposed to work upon is, you should work upon the fundamentals of it to convert some indicator into a value so that it can be embedded in a software, and the software can convert that into a meaningful output for doing any type of analysis. For example, this could be a more interesting one. Recently, it has happened. The TikTok is something which is, I think all of you know about very well. I think most of you must have had it. About 20 seconds clip, a video clip of people doing all sort of nonsense has been put over there in the TikTok. And the TikTok was formerly, there was somebody called Zhang, a former Microsoft employee, founded a company called BitDance in March 2018. And but before that, in 2012, Zhang launched his first mobile application, something on some other mobile application. But later he founded this, 2018, he founded this. Then in Chinese entrepreneur VentureBet, that is this BitDance, almost it has become it was trying to catch up. And then this BitDance bought another 4-year-old, something called Musical.ly, which had about 200 million subscribers for the price of $900 million. And they launched August 2018 TikTok. That is, after the 5 months of initiating BitDance, they came in with a software called TikTok. That was the one launched in August 2018. Within 3 months after launch, they gained 30 million subscribers. And you know, just this left-hand side, you see that, you know, the number of downloads which you could see right from WhatsApp, Messenger, TikTok, Facebook. You know, TikTok exceeded everything. Both you can see Google Play as well as App Store for both Apple as well as Android. You know how much amount of money they make it? Just see amount of money. When you're using TikTok, you see a lot of advertisements. The most important thing in the TikTok is not the 20-second video what you have uploaded, my dear. You have to understand that there is a big business behind it. What is this big business? They were using that as a platform advertisement. What advertisements will lead to? You click the advertisement, and Alibaba is giving advertisement, lot of gadgets. They start selling the gadgets. their revenue went on. This graph shows that how much revenue went on in January 2019. It has reached about $12 million is the revenue they could generate, and it was exponentially increasing it. So this is something like TikTok is like not like Facebook, Netflix, Spotify, and or YouTube, because TikTok uses artificial intelligence algorithm. Don't get carried away by the way artificial intelligence. In today's time, you can easily understand artificial intelligence. There's something not very, what do you call? You are trying to make a software to know to learn the process what you're trying to be. And that process, I just explain you simply by TikTok. The TikTok, you are watching a video which is of your interest. For example, you like cricket. You start watching cricket. You already your phone is configured with the TikTok server. Now what happened is, after that it is continuously watching. When you're watching cricket, it classifies. Okay, he likes cricket. Suppose you watch a garden, you like a flower, you just talks about it. It just adds to your flower. So the algorithm is setting you. Your liking is fixed within 20 likings or 25 likings only. In that 25 likings, they will be keep on giving all the videos which are related to you. Now you are addicted. For hours together, you will be sitting with the TikTok and without knowing that you are addicted. Now, in between that, you will be having something related to your liking. Suppose you are getting a good quality bat and a bat, you are getting it. If you are a cricket, you like cricket, you go for it. You just click it, you go for ordering it. So therefore, that not like a Facebook, just they give advertisement, or third-party advertisement. They never use artificial intelligence to understand, to recommend post according to your liking. So, but today, every software giant is now looking at it. The moment TikTok was banned, now Google started investing in India. So they see that the moment something goes on, the opportunity goes to somewhere else. So never think that something comes as free. It always comes with a quote and inverted quotes that you will never be able to understand. The more intelligence you have is that you try to understand that and try to optimize it. But this I'm telling you an opportunity. So artificial intelligence in now today. Now I know that there is a company in IIT. They are trying to master the way that about our different locations. They are trying to develop an artificial intelligence of a type of drugs being consumed in the different location. So now that then soon you will be getting a pharma industry being diverted. Okay, in this cluster, this requirement of this drug is high. In this cluster, requirement of this drug is high, so that they promote that only drug in that particular area on that particular season. So by this information is known to most of our pharma companies, which month, which requirement. For example, if you're having in the month of October or in the month of August, September, people start having a running nose. They will be in need of cetirizine. They will be having anti-cough formula. So all these people look for a rainy season for this. And that's how they position it. In the summertime, I think hardly they sell anything. But by using this kind of artificial intelligence, they know what type of product to be used, where it has to be used. Everything is converted into knowledge, and knowledge is money. There is nothing wrong in earning money, as long as you earn through a proper means, rather than that artificially inflating price or hijacking somebody. This is about the theoretical. But I must tell you about something which is inspired me. Last year I was selected for international forum for visiting Japan to attend the international innovation meeting. So I happened to see the company of Shimadzu. I think most of you guys are very familiar with Shimadzu. Shimadzu, most of you must be having the HPLCs of Shimadzu, and you have mass spectrometry of Shimadzu. Shimadzu works in all areas. Probably you must be having even spectrophotometer from Shimadzu. I was always wondering that how Japan progressed so well. After Second World War, everything was demolished. Everything was demolished, and science. Japan didn't have any big scientists or many big discoveries or inventions happened in Japan. Everything happened in Europe, or somewhere in the Europe only it is migrated over there. So I entered, this picture is a beautiful Phoenix Byaudin temple, which was built in 1998. Nearly you would consider this when the Tanjore temple was built by Rajaraja Chola, and Tanjore, this temple was built over there. And at Uj. So when I went to the company, I could happen to see there was a museum in which I could meet this innovator of Shimadzu. His name is Shimadzu. And about 150 years ago, he was alive and he initiated something. I mean, then it's a family of Shimadzu. And in the second one, suppose he lived nearby, the second generation. Now it went on so many about it, but the company is about 150 years old. But I was wondering, how these things happened over there. And when I just went inside to understand more about it, there is somebody called Genzo Shimadzu. This is the innovator. He was born in 1873, before the Second World War. And this was something very interesting that in 1877, the government requested him to coat the silk fabric with gum, they said, because those days balloons cannot be made. So what made America to get pestered about dropping a nuclear bomb on in Japan? I was always having this interest that what irritated them. You will not believe the Japanese made air balloons. I mean, the air balloons through which they just attached a bomb and they sent it across the ocean so that it can go and fall over there in America and it explode. So something, is something like a mosquito type of torture they were having it, and they could do it with a very cheap cost. And you will not believe that the balloons, they didn't require much of money to make this. And this guy has been, Genzo Shimadzu has been given the task of making these balloons. And he took a silk fabric, he coated the silk fabric with a resin, that is a gum, and a plant resin, and created it which can withstand air and the heated air. So the balloons cost America much of damage in America, and during the time of the war. So that after that, if you just get inside the fine details of it, it's beautiful that they made a small battery and they attached it with that, and the sand ballast are being fixed. So if it goes to reach a good height from Japan through Pacific Ocean, they travel through the air and just enter into the America, and it is dropped. It's all time and weather calculated one, they could make it up. I must thank this Shimadzu Museum for giving these beautiful pictures. I could correlate everything later when I came back to India, but this is how they just could do all these things. I think none of us know about this kind of information. How Japan, really America was bothered, because nobody could bother them more than that of Japanese. That's why they airdropped the bomb. So that when I was just when I was during my PhD, I was in University of Würzburg, where my laboratory was just next to Röntgen's laboratory, where Röntgen discovered X-ray. My next to wall is Röntgen's lab. So I happened to visit his lab. I used to feel so proud that, Röntgen worked over there, and so I was so happy to see those X-ray tubes. But you will not believe the same X-ray tube I found in the Shimadzu Museum. So that means Japanese, even today, very few of them, they speak good English. In Germans, even today, there's very few of them speak good English. But neither Japanese know German, or not German know Japanese. But at the same time, in 1895, when X-ray tube was discovered by Röntgen, in 1897, this information reached them. And you see that this picture which I have taken in 1896 in Kyoto, Shimadzu invented X-ray machine, which is much powerful than the original invention of Röntgen. And you see that these, made between 1917 and 1936, they made a lot of X-ray tubes and they start commercializing it. See that some information which is published in some journal, this went on there and they picked it up, they made the innovations. Now, this is the fundamental development. And then I was interested at the time, what were we doing? What happened to the science in India? Do we had something about it? So because as an Indian, I was also highly interested in knowing in 1897, what happened to India? To my surprise, that is a time, these are all, other inventions I could see over there. In 1895, the same time, J.C. Bose discovered electromagnetic wave to ignite gunpowder and to ring a bell from a distance, which is reported in Science. The article came, who discovered radio waves? Radio waves. If the credit goes now to J.C. Bose, then we always been taught Marconi discovered radio, but well, the credit goes to him also. But He has demonstrated it in Kolkata. He ignited at a distance without wire, he ignited a gunpowder. And similar type of experiment I could see over there also. See the parallelity. What happened is that we were also having similar capability, but while on the way, we missed all of them somehow. We did not develop from that stage towards the innovation stage, what these countries enjoy, whether it could be Germany or could be Japan, or it could be even China. But we somewhere lost it because we have a colonial mindset that we wanted to work as a slave with somebody. We don't want to innovate, and we just look forward for a salary. They learned so much about it. In 1947, they made electron microscopes. See, none of them are their discoveries so far, okay? But later, in 2000, a great discovery came out from Shimadzu. And that was something which was, see, these are all the developments I could see over there. 1978, their HPLC system. That's not that I see Waters was the discoverer of this or Millipore. I could see so much of commercial system. They developed it. I think some of us have also worked on this. I remember using this electric balance somewhere in I think maybe in the graduation also I used it, and post-graduation I used this electric balance for measuring it. So Shimadzu plays a bigger role in our this thing. But the most interesting thing is in that visit, what I understood is that Koji Tanaka in 2004, I mean, he got the Nobel for the discovery of for discovery in the mass spectrometry, right? But when I think all of you know about him, this guy Tanaka, he shared with another American. When I met him recently, he was a very simple guy. He's a very shy type. He's even today, he's only a graduate, not even a postgraduate, not even a PhD. So when all of us, when we met him, right, he doesn't want to meet us because he feels very shy to meeting people. And today, this discovery in the mass spectrometry, especially, he discovered that laser ionization, MALDI, matrix-assisted laser desorption ionization technology. He is a graduate, electric engineer, a graduate who discovered this. I mean, I don't think even they were master's student or master's or PhD could think of that, somebody's going to get a discovery like that. So he's a graduate, he got such a type of discovery for which he has been conferred Nobel for his discovery. Really, today we enjoy those spectrometers in our lab, because of those the discovery of him. So why am I telling you is that not necessary that you need to have very high education. We need to have, see where we are using MALDI in biology. What is he? He's an engineer. He's an electrical engineer. So electrical engineer is working on mass spectrometry and biological sciences. He's trying to develop it. Well, what are we? We have so much of avenues. So this is something that the science reflected in intelligent innovations. So this is something that, in the laboratory, I was very happy to be with them to know about the innovations about it. It's a Shimadzu Global Innovation Summit of 2019. I could say, so what the takeaway message over there is that for those who can't innovate, don't enter. This is what I could feel from the Shimadzu company. I took this picture there only. So, these are all something that, a small zeotrope. So you say something like, I think you must have seen this small instrument, type of instrument that somebody is continuously jumping. It is something, a small optical illusion, and based upon which, film industry, those moving cinematography pictures came up based upon this innovation, right? So why am I telling you this is that for an innovative mind, you don't have to be something that, to be a master of some field. You should be able to always get into it. So what is more important to academic to train? See, I could not, I just briefly cover our innovation, something which we did at our lab. The recent innovation which fetched a BIRAC big grant for, see, basically that we have a problem. We are seeing that the microbes are emerging with resistance, and for ocular infections, we are in need of new drugs. Therefore, we develop newer drugs. We study in human, we study in animal. We try to develop the formulation and we make it available in the market. This is what we always do it. So in our hospital pharmacy, we try to handle these drugs because the whole pharmacy is in our disposal. So we try to do many things like. So what I found is that many of the drugs we cannot make it as an eye drop because they are unstable in nature. They get metabolized. So that is an opportunity for me because we need our pharmacy to make it. So immediately we dispense it. It can be used for 1 or 2 days. We can't use it beyond that. Therefore, this is one of our laboratories in which we do a lot of extemporaneous release formulations, and it is used every day. To such an extent, we make ampules for injections, and we have a sterile facility of Class 10. Class 10 facility, right? You have a completely aseptic zone in which we make ampules, but the ampules are made by hand even today. And it is used, we must have injected more than last 15 years, we must have injected more than 1 lakh eyes. So this is one of our facility. So what we did is that when we did the stability testing on piperacillin and tazobactam, we found they are not stable. Therefore, we can't make a drug formulation available in the market, or you have to make it as a powder and you need a syringe and a needle. They don't have to mix it. So, you cannot allow the patient to use the sharp needles, and it is not allowed. So therefore, we found it is an opportunity. Then we started developing it. So all the spectrophotometer studies, all the studies in mass spectrometry, everything and confirmed, every stability data we have done it. Then the innovation came up with this. We developed a small instrument called TransRecon. And this instrument is came up with all the. So what we do is, it's a very simple technique. Don't expect that you have science about it. What we did is last year, now we got our done. This is solid state trial dispensing technology for unstable drugs. The drug is kept in 2 different vials. One is having the chlorine powder, which is sterile. Of course, the bottle is sealed with a plastic cap. And this is having a separate liquid, which is for inclusion. So this is a sterile adapter. So we adapt on it. The adapter opens this bottle and you plug the electrode from it. It is a plastic vial. So you gently squeeze the vial. Transfers the liquid into the solvent. Now this is getting reconstituted. And you just gently shake it. Now the patient can use it easily. So now the vial will go into all the it's all easily available for use. It's a very good innovation. So this was the award of BIRAC BIG grant, that is a Biotechnology Ignition grant. I'll show you a small patient demonstration. Now the patient need not to go to anywhere. The doctor need not to have a a separate facility. Now the pharma industry can do this differently. See, this is a vial which is having a there's the drug, this trial cap. Now this is something that the liquid is kept as different vial. This drug is an unstable compound, but the drug has to be instilled every 2 hours for the patient for next 3 days. So in next 3 days, I know very well that the drug will be finished. So this technology, what we developed is something different. So that has to be patented right now. All things is patented. Now we are now trying to commercialize this. So it's a double scientific attachment, and we have a very short medium. We just spread it from it. And after that, we squeeze it. The transfers to the version slowly. And that's it. Now
show this to us. Okay, go ahead. No. Press again.
You must have actually put will be in the market. So we are hoping so. So this is like similarly that that even in the book, I hope that all of you must be knowing about a book called the Lippincott Illustrated Reviews in Pharmacology. This is again, we wanted to bring this drug. This book was available in the Western media. The company was interested in converting it into Indian edition, where Indian students can understand the concept of pharmacology. The pharmacology is very difficult to remember the drug names, their action, their side effect. But the moment when you try to make them understand based upon the mechanism in a visual form, the memory is very strong. Therefore, all of us, we know about Lippincott physiology. Now we have got Lippincott pharmacology. I think if you don't have, please buy the book, those who are doing pharmacology. And it happened that myself and Professor Sangeeta Sharma, we edited this book to Indianize this book, available. Now we are working on it to make it as a 3-dimensional also. So if you are in academics, you wanted to convert, if you are in academics and you wanted handling the project innovations, you wanted to take it further. So it is a very exciting field. Innovations are very exciting. In progress in biomedical innovation, never been more rapid and exciting than today. Today, everything is possible. Today, you try to understand a little bit more on Python, you'll be able to understand how to work with Python. And today, we can Anaconda, you can use Anaconda, you can use Conda. Now you can do artificial intelligence sitting at your home PC is possible. So there is a clinical pool. You go to a clinic, you understand a lot of requirements, unmet need. That gives the startup for you. So you try to solve the problem. Never say it is a problem. When a problem comes up, it comes with it is looking for it for you for the innovation. Then the invention has new tools, the application in which move medicine into new areas. So you can go across the domain to solve a problem. And third factor is in a developing world, if you make anything in low cost and high volume products, then definitely you hit a jackpot. So when you have an idea of concept, then you make a working model in the lab. Today, if you happen to come to, if possible, the next time if I give a talk on IPR, I will definitely show you about how do we do 3D printing, how do we do 3D printing, how do we make these things possible. You don't need to buy a sophisticated software and all. It's all easy, it's possible. And the free software also available. We convert it and the working model, we make it in the lab, they make a prototype. Then, there are funding agency come in. You go to, it's an open call. You can go to BIRAC, the open call comes up, you apply. There are 3 rounds of analysis. If it comes out to be good, you get a grant and you can incubate yourself. There is there is a difference between an incubator in your lab and what we call a bio-incubator in the academic, in the entrepreneurship. This incubator is something like our lab incubator. This incubator allows you to start a company in their milieu. So, now the agencies like BILAC or the agencies like the government agencies like Atal Innovation Fund, they give money for making incubators for the pharmaceutical, for the pharmacologists and universities. Or you combine together, you make the incubator, allow your student to incubate in that. If you ever happen to go to BITS Hyderabad, or if you go to BITS Ranchi, or if you go to BITS Pilani, you see the incubator is simultaneously running. All pharmacy students are making use of it. And similar setup, if it comes somewhere else also, it will be of great use. And there are something called Biopark. If you happen to go to see Biopark in Chennai, go and see. There are many companies that are operating, and many of them are in collaboration with us. A few of them are collaborating with us for new drug development. We do interface for new drug development because of our capabilities. We work with many companies in India and abroad to make it possible, all innovations. No more we are interested, we do good science, but good science is for making thesis work. But we almost stopped working on plant extracts. No more plant extracts unless otherwise you take a plant extract, isolate a principle, take the principle and go ahead with understanding more about it or making semi-synthetic modification. Everything is okay. This is a whole process how innovation translation takes place between academic entrepreneurship in itself. So what we call it as TRL1, that is a technology readiness 1 level to technology readiness level 10. What we call this whole process as technology readiness level. For example, you have got an idea. Now ideation has happened. Now ideation, you try to make a proof of concept. You have to make a miniature of it and try to look forward for funding. Today, when you get into any of the established incubators, either IKPL in Hyderabad, private incubators are very pushy, very good, or sometimes government incubators like IITs have incubators and good universities have incubators. In I think Trichy also they have an incubator. So you go to these incubators and allow your company to be incubated. You will be able to get some amount of money for your salary also in that. And there are many people funded. There are so many people. You see, MSME. This is a government funding, or BIRAC funds it, DST, ICMR, angel investor, grant in aid, intramural, own investment. So many companies. First, you put a small amount of company. Sometime one of your uncle can fund it. a small amount of money. If he's a good businessman, he will not allow you to go. But everything is done properly with the proper agreements. Within 2 to 3 years, patents are getting generated, the product is getting developed, and either the product is acquired by another company. The moment you make a product, other pharma company will ask you, you sell it to me, sell the product to me, I'll pay money. Most of the Indian pharma companies I have encountered, the moment when I go there, they say, you give me the product, I'll pay you money. But they will never come to you for developing a product. This is something, a big problem. But anyway, there's an opportunity also for us. So, or you sell the product, you walk away and go and do again another innovation. I am an innovator. I don't want to get inside only one company. We go like this only. So, or sometimes they acquire you equity based. They will say, okay, I will give you 20% of share, 80% is mine. I will make the product, I will sell it, I will give you money. So different ways through which it is handled. I think, if possible, somebody else will discuss about this in detail. And this is how we convert a proof of concept to commercialization. Okay. So with this, I could not cover a few aspects because, I think I've given you a complete overview about everywhere innovation is possible. And please do not publish your article in online journals. As an editor of pharmacology in editor pharmacology of Indian Journal of Physiology Pharmacology, the articles which I get it for printing is really pathetic. I am not happy with those publications. Many a times we see, even they are lifted from already published in the Predator journals, something is published, they've taken it and they just put their own values and they publish it. Don't think we are fools. We are all working with so much of experience. Just seeing the data 1 week, one will be able to say whether this person has done it or it is cooked up. It won't take much of time for us. And so much of, this kind of, never encouraging plagiarism. Don't copy anybody's things by yourself. I think this, I don't want to, in the interest of time, I'm not going into copyright. It's a bigger area. Probably next time, if time permits, again, I will talk to you about what is the copyright, what are all the places through which you have to be careful, where another place you'll be able to go, what are the normal ethics, and how do we try to encash money? How do you be able to earn money out of copyright also? Okay. This is something about our lab, which you see here is high performance high precision bioanalytical laboratory. This is awarded by DST FIST grant, and we developed a micro dialysis technique, and this is a molecular dynamics laboratory, and we have a very good sterile dispensing facility. We have a small synthetic facility. We have a microwave, a commercial microwave, is a typical microwave synthesizer, and we have a very splendid pharmacology laboratory. Now, most of them are according to the standards what we look for it for. So innovation is always, unlimited. I always see the thing inside. So that innovation is something that don't think that only you need so much of intelligence to make this. See, this guy is wearing a helmet while he's cutting onion. You call this is again a small innovation. It's just for fun on the lighter side. So this gentleman has found a new place for holding his a mobile phone, and you see that he fixed the mobile phone to his mouth, so it becomes his walkie-talkie while he's driving. And you see this gentleman is more innovative that he used this a basket to ferry his kids to the school. You see, all of them are in tie, shoes, and boots. See, I really don't know why in a climate like South India where it's so hot, why kids are being harassed wearing tie. I really don't know. And shoes, there should be a little more logic behind wearing all this kind of thing. But it's interesting that now it's become very problematic. If I have a dog, and the dog should also do some work. Therefore, a person who is a handicapped, but he is being ferried away by this dog, so that's fun, right? Something which is innovative. This is something very, very important. Those days, somebody loses his motorbike, people used to say, you go and find out in a village somewhere it is pumping water. I never understood what do they mean by that. You see that now he coupled it with a machine to pump water in the village. Well, this is something little more advanced brain. Somebody wanted to chill, I think drink of the day. I don't want to encourage any one of you, but this is a way that how you chilled it. This is very interesting. Probably this is a hot summer in which you wanted to cool it. This is ultimate innovation. This is not just for fun, okay? Somebody put such a big lock, when he leaves the slipper outside. So this is all a little fun, okay? Well, this guy had an ambition of driving a Maruti, but now you see how he made it, right? Half Maruti sold, one is being selected in that. This guy has made a small low-cost water heater from a burner by using these tubes, copper tubes. Somebody made as a bottle trap. I think this is something you have a lot of videos in YouTube to live in the water. This trap for getting the mouse trap at home. And somebody he doesn't he put a normal chair in the car to drive. It's much more easy. He doesn't want to invest on that big money. And they invented some new innovation of using an old used a bottle for as a what do you call this allowed to replace the refill pack with this. This is more interesting innovation. This guy wanted this chilled air from this water cooler to go to 2 rooms. He used his pant. So the pant has 2 legs. The one leg will throw this side and one leg will throw that side. See, these are all just fun, actually. I mean, this is a minimum amount of people one could carry. I don't know. But see, this is very interesting that, some people, this is something that people misuse technology also. See, he has a false hand and he is doing, he's using mobile phone to copy something. And this is the most interesting innovation is a person solved the problem altogether to manage his mother and his wife together on the same bike. So can it be anything more than this interesting? And somebody fixed the AC in the car or the older Fiat to get AC because Fiats don't have that kind of facility. Finally, I should end up this lecture by saying that innovations are honored and rewarded. Entrepreneurship is the strategy which is encouraged by Startup India. I must tell you all those who are in different colleges to come up with somewhere making an environment suitable for young graduates and postgraduate and PhDs to transform their idea into a product. And we should encourage the product reaching the market so that altogether it is good for college, it is good for the student, it is good for the society, and that is a way of pay back our due for the society for people those who are contributing towards that. With this, I thank. This is my email. If somebody wants to communicate, they can communicate. Somebody wants to come for a PhD to my lab. That those who are highly motivated students, I really encourage motivated students coming for research in innovations. They can always send a CV that we do have positions coming up off and on, and he will be able to recruit you so that you'll be able to get a decent salary of a JRF, and you'll be able to work over there. Okay. So with this, I just conclude my talk, and I thank the whole team of SSM, right from Chairman Ilavarasan and my classmate, my close friends, Sangamesaran and Dr. Venkatraman, and the coordinators, Mani, Subramanian and Kannan, Vaijantimala, everybody. Thank you very much for making these efforts to make this possible. And thanks a lot for you.
Thank you, sir. Thank you, sir, for the wonderful presentation.
Yes, thank you very much.
Sir. Now the session is open for Q&A. Over to Mr. Mohan Raj, Department of Pharmacology.
Oh, Mohan Raj. Yes, I remember Mohan Raj. How are you?
Hello, sir. How are you, sir? I am fine, sir. What about you?
Great, great, great. He's one of them. He visited my labs. It's good. I'm happy.
Yes, sure, sir. Sure, sir. Thank you, sir. Thank you very much. Good afternoon to all. Before moving to the session, I would like to express my delightful occasions with enthusiastic personality, Professor Dr. Tirumurthy Velpandiyan, sir, for his lively and inspiring speech in this COVID-19 pandemic conditions too. Good afternoon, sir. You explained in a detailed manner about innovations with more examples. First one is the full string Indian innovations, vampire bat medicines, desmotiflage, and antibiotic from lizard. Next, lugdinin is a newest powerful antibiotic isolated from microorganisms. And after your valuable words in your lab research, everyone now came to know the valuable antibiotic will get in from a human eye. And another one, the excellent innovations about an onion peel produce natural dye. The active compound is the cyanidin 3 glycosides. We learned about Eri silk natural dye. Thank you, sir. Sir, your words are strongly promoted us about the artificial intelligence. Thank you so much. With your valuable words, we clearly understood every innovation is most important for our country. we have to appreciate each and every innovations, either is a simple manner or in a or in a more manner. Thank you so much, sir. Now we'll start our question and answer sessions. Most of the valuable participants are start to ask the questions.
Really happy.
First one is few minutes. Sir. What about the exposure experience for your budding research in India?
Yes, that is something that, you know, so far the PhD students, those who join in our place, I mean, people so far, I could see only very less percentage of people are motivated in doing something new, something which is making their life more productive. Mostly people are looking for it for a job. I mean, by looking, I mean, I'm not telling that, you know, I mean, looking for a job is something bad, but what happens is that the job is required. Perfect. We totally agree with that. But you have to make yourself eligible for the job. It's not that something which I come here, I send my CV. What is your CV? People don't even have a simple hobby, right? I expect some people to have a hobby. You know, most of the hobby of people are one of to take it on the lighter side. One of the girl who came for interview, she said, she says that my hobby is sleeping. So if such a type of students, when they come and listening to music or listening to reading books, listening to music, when I ask that what are you good at? Can you able to do something? Can you able to play? Can you able to do you know, anything in a handicraft? Can you do a good drawing? Can you do anything which makes you call that the hobby is innovative? They don't have. And you know what, we always try to insist that study, read and do route learning and to secure marks. But finally, when they land up in higher education, they expect the teachers to come and teach them that how to do research. They come in such a way, I am here, give me salary. If you have talent, take my work from me. So that is not a way how research works. I expect the research is something like, I just before this talk, I was discussing with my friends, and you know, we were discussing that. See, look, my lab, you know, I'm just sitting like a student. I wish to be a student throughout my career. I never want to be somebody who is, you know, sitting in front of a big table and I ask my student to stand. It's not like that. I sit with student, I learn with student. So this is how one be supposed to be, and I expect the student to be like that also. So in the young students, the research, a new atmosphere, I expect them to come forward, and if they have such a type of interest, that lots of opportunities for them to come up.
Thank you, sir. Next question. May I know whether we can apply for patent for an innovative idea?
Yes, absolutely, and one should do it. Without patenting, don't publish. You know what is happening today? If you make any novel drug delivery, for example, you know, we left doing drug delivery about 20 years back. No more drug delivery. You know why? Neither the polymer is my patent, nor the drug is my invention. I am trying to make a khichdi, right? You try to put this and put that, put this, put everything together in different combinations, and you come out something which is not your own. It is like a kitchen chemistry. So what is the novelty in your formulation which is not available or existing in the knowledge? So always the patent examiner look forward for something in this. What is something novel? What you're trying to prove in that innovation? What if the innovation is made? You have to apply for a patent. It's very simple, you know, cheap. It's not very expensive. It has to be drafted, but you should take a professional help. People, those who work in this area is called attorneys. The patent attorneys. They are different people. They are not like lawyers. So they make application. If you even sing a song, take a copyright. That is possible. And you know, if you make something that I did not touch the area of copyright, probably next time if Dr. Sangameswaran makes it possible, I won't mind to give another lecture on intellectual property rights, especially that what all the how to do patenting is a different area altogether that I will discuss. But it's without innovation, without patenting, don't go for publication, and it is possible. Innovation can be patented. There are different type of patents. One is a design patent, another one is a design patent. Then we have copyright, and we have other form GI, and you've got other subdivisions of patents. You will be able to handle it very well. But majority in this area, mostly copyright, designs, this thing, I mean, patent, and this, you'll be able to cover most of the things. You should do it.
Thank you, sir. And third questions. What about cockroach radioactive stability property? How to do the research? I'm more interested in that.
Yeah. It is. Cockroach is having a layer around the wings are capable of reflecting the waves, and all this. For example, that the microwave reflecting property of them. For example, this is a beautiful observation. I really appreciate the student asked this question. See, you must be having a microwave at your home. In microwave, keep a water boils. But you leave a cockroach, the cockroach will not die. Cockroach will not be burnt, right? This is a beautiful observation this student made. I appreciate it, because now there is something that they have which reflects it back, and this gives an opportunity. I mean, she or he is asking in an open forum. So some things that he should not ask in an open forum like this, because you expose the idea. The moment idea goes off, it is not yours. If you apply for patent, patenters will say, examiner will say that, look, this information is already disclosed. So I was telling you about this, in drug delivery, you go for any patent, you will not get it, because all pharmaceutical colleges, pharma colleges, all of them published so much about drug delivery, nothing is left for patenting. Without patent, no company will take up this and make a product. Therefore, you killed it. This is what it is. I hope you understand what does it mean.
Thank you, sir. Next questions. What's the scope of clinical data management in future?
Wonderful. But clinical data management, not only clinical data management, you should also learn along with clinical data management. You should also be able to understand big data, data tunneling, data analysis. Apart from people are doing B.Pharm, M.Pharm, they should also go for extra things like this, which are not related to pharmacy or pharmaceutical sciences. It's another area. Data science is a common area. And today, if you get into data science has such a big depth, and in which artificial intelligence will come in differently. Do it. Good. You will fit very uniquely in some company. And don't look into it. Who is calling for what? By the way, you will be one among the crowd. You should have a unique qualification. Therefore, you are the only one fit into that. And companies will love to have it. It's possible. When you start working in that area, you start publishing, people will come to know.
Thank you so much, sir. And another questions.
Yes.
What are the basic needs in research for patent?
Patent requires novelty. What is novelty is even novelty means something which is not known before it is being disclosed by the person. I mean, I published, I made some new innovation. I published in an online journal, and now I'm going to patent office to file a patent. He will say, no, you already disclosed it. No more you are able to patent it. Patent gives a life for the innovation. So novelty is important. Novelty is something which is not available. The information is not available or not obvious for a skilled person or in the on the field of science.
Thank you, sir. Another questions. What's the scope of SAS?
SAS. Well, that's good. It's good. I think, or SAS. I think one should learn these things. I sometimes feel that I should learn SAS, but I mean, I'm not able to. Well, I could get into AI, We could do so much into electronics. We could do into 3D printing. We do it with designing. But SAS, I could not go. But well, this is a way that if you're trying to take your career in that way, you know, what you like, what your mind says, go. Do it. Do it with interest. Don't do it for salary. Don't do it for job. Do it for your interest. Interest makes you a perfect person. It's good. Any additional qualification is good.
Thank you, sir. Next questions. From present scenario, advancement of clinical data, is it important for BPharm student?
See, basically, that the question is that what is he going to do after BPharm, right? I think many of the questions, even, you know, when I came out after doing BPharm, actually, I was not, I was looking as a, you know, to get into as a trainee chemist somewhere in a company. So I went for an interview. So after the interview, there were about 80, 90 people went for the trainee chemist interview. And that interview, after interviewing me, that fellow said that, I think your knowledge, I think you should not join at this position because we have many people for it. I think I would suggest you have a lot of inquisitiveness and you think go for higher education. You know, that gentleman told me during the interview, otherwise I would have joined, I was selected. I should have joined as a trainee chemist. So what happens is that, you know, your knowledge, anything which goes, you have an extra knowledge, you always get it. But with BPharm itself, you are going to look for it for a job. Obviously, you need to master all the skills. So by doing MPharm, you are only getting into academic ladder. Otherwise, BPharm is more than enough to call you as a full-fledged pharmacist. By doing MPharm, you are not a super pharmacist. By doing PhD, you are not a eternal pharmacist. It's something like a basic qualification of pharmacist comes with a BPharm qualification. With that, you do any extra that makes you more, you know, expert, as it gives you so much of push for a particular area. Do it. It will be of help. But enter into domain where you have a reservation for your basic qualification. Don't get into the line where you have nothing to do. So your requirement is always there. Yes.
Thank you, sir. Most of the BPharm students are asked the valuable question is, what we need to develop while doing BPharm for future research in drug development?
Well, I mean, in the BPharm, what is more important is that basically that why always I feel is that, you know, in BPharm is luckily in Tamil Nadu major, Dr. MGR Medical University, you have a 6 months project. Am I right? You're still there?
Yes, sir.
Well, that's good. So, you know, such a type of facility is not even available for medical students. Do you know that?
Sure, absolutely.
So doing MBBS, they don't do it. Only for BPharm, BTech, B, these people, those who are having technocrats, do have that 6 months project work. In that 6 months project work, 4 or 5 of you combine together, 4 of you join together and make that possible, right? A small innovation. Not necessary that it's a drug discovery, because sometimes drug discovery is much, you know, it requires today's drug discovery is beyond so much of science. So you have to look for several things inside. Instead, pharma industry is not restricted only to drug, right? So it is having several things inside. Like I did not show you one of the invention, which I think one of the recent innovation which came up, through which they designed a probe which can be used to do injection inside the bone marrow, inside the bone. Like you can give IV drip through bone marrow, and somebody has designed it on their marketing in India. It's good. And one of my colleague from here in Delhi, in AIIMS, he designed a ventilator for some time back, and that ventilator, I think mostly you must have seen in the news and all, that ventilator is coming. So, you know, that kind of any join together, sorry, make something like, you know, a small innovation, microneedles. But do one thing, if something is substantially coming up, apply for a patent before you go for publication. Don't jump into this online journal, giving 800 rupees and going for publication. Join young graduate students, 4 or 5 of you join together, make a product. What's wrong with that? You make a product which should solve a problem, which should ease some problem. So it is the incremental value as compared to the existing one. You have to apply your mind. I cannot tell you that do this, do this, do this. But well, if you come out with an idea, I can tell you, okay, you can do this, you can do that. So you have to, in the colleges, they have to identify somebody who is having such a type of interest among faculty and supposed to give a very encouraging opinion to them to develop such a type of thing and keep a target that this year in BPharm we have a batch of 50 students in which we definitely try to develop 3 or 4 products which are useful. You will be having n number of products, but it has to come to market.
Thank you, sir. What is the scope of pharmacovigilance in India for BPharm students and PharmD students?
Well, I think pharmacovigilance has taken up very well. It's a good shape. After I believe that earlier I was in the National Pharmacovigilance System, center, when I was a senior resident of pharmacology at AIIMS, because that time we were hosting pharmacovigilance. Rather, it is now gone. Now Kalai is handling it. Kalai is again one of our junior. He is doing very well and he is handling it. And now I feel pharmacovigilance is routing very well. And but it is yet to create enough amount of job opportunities so that for students. But the line is there. It's a green line. For PharmD students, we are yet to see. We are also looking forward for finding an avenue to bring PharmD students to AIIMS. I'm working on it. So I think soon we'll be having a small talk with Dr. Suresh also about it, because I think I need a little support from PCI to do that. So if I could bring it inside, it'll be a great thing. If I could bring it into AIIMS, I think I'll be able to bring it everywhere in India. So PharmD, we are looking for a different role altogether. But in some time, what missed, we know there is a missing link between the medical institution and pharmacy. We are trying to bridge the gap. Now fairly AIIMS know that our capabilities are pharmaceutical sciences. Therefore, unless you prove yourself somewhere, these places you cannot. So we are looking for it. But pharmacovigilance per se, it is having a good role to play. It is having, but job opportunities is yet to create that much, but it is on the rising stage. That much only I can say.
Yes, sir. Thank you. Another participants are asked, what is the scope of medical coding field in India?
Oh yes, that's another field. Some of the students who came for interview, when I interview them, they say the medical coding. A girl who came that day, she was telling that I'm working on that is what do you call centers, that knowledge call centers, right? There be KPOs. She was working on a KPO and she's decoding ECG data. Wow, that's interesting. And her training is from pharmacology, and she's doing coding data for this thing and prescription coding and this coding. But there are some regions where where you don't need pharmacy expertise. Those areas we should not enter, because that will not take you for a long way. You should enter the place where your position can be maintained and your knowledge can be used. Don't fight with people, those who can come from other fields, right? We don't want to really. Otherwise, sometime what will happen, for a cheaper cost, they will take them and they'll throw you out. So that's not a way. Try to maintain your place. Then you can apply your pharmacy knowledge, do it.
Thank you so much, sir. Last question. Compared to efficiency of drug extract from animal and inorganic synthetic drugs, and why synthetic drugs are reached more in market and available commercial more?
Well, this is a good question. Very good question, I must say. See, what happened is that, this is what the student perception and a more practical perception of doing things. As a student, what you always look for is that I will make something cheap. I will make something easily made, and things like that. It's a new innovation. Companies can make it. This will also work like a drug. This is the way how we talk about it. But when you come to the logistics, just understand. Suppose I isolate a new compound from a plant. My real problem is that I cannot get a patent on it. There is a problem because it is a natural product. I cannot get a patent. What patent gives? Patent gives you exclusivity. See, you have not discovered that plant. that you only just explore some activity, and you when you patent it, you have to go through all stages. Now you mix with this, some synergism and things like that they try to work upon. But company, what they want, a drug when you wanted, today in your lab you gave to animal 100 grams or 10 grams, you have given it to the mice or rat. But when you are making a company, most of us, we understand we have to make it in kilos or tons even. So for example, that I'm trying to reach a drug in the market, I might require 300 kgs of it. 300 kgs of a plant product is enough to kill away a complete forest. Unless you do, foresting, you try to develop crops like you see, I could see ashwagandha is being made, vinca rosea has been made. But see, these things again, you are dependent upon another system for generation. If you are not able to get a value for the product which is produced, you're lost. So when you develop a plant-based product, you have to convert into somewhere semi-synthetic. You apply a patent, and that patent gives you exclusivity. That exclusivity allow you to sell it to somebody or develop it. It requires little more money, heavy money. That money has to be pumped in. Only if you have a patent, that money comes in. Otherwise, it doesn't come in. So you cannot do a clinical trial unless you do a CT, that is a randomized clinical trial. Nobody is going to believe your data. Therefore, you killed it. Nobody will touch it again. So when you try to isolate it, identify it, you try to make it, then you have to make a semi-synthetic derivative. You will not believe bromhexin. You remember that Adathara Vasaka? Adathara Vasaka extract is used for cough. We know bucolitic, we know very well. It is known in the literature, old Ayurvedic literature. But the British company who took it over, when the innovation has been transformed, it has been transformed into bromhexin as into a semi-synthetic derivative. So similarly, like atropine is a bronchodilator. Now you use ipratropium bromide. So you try to make a semi-synthetic derivative of it so that you can patent it, you can control it, you can quality control it, you can understand the stability of it, you understand the ADME toxicities of it. Everything you do, pumping crores of money. If you don't have a patent, somebody comes tomorrow morning, start making it, and you will never get your money back. But who is going to invest money? The bank is going to invest money. Bank invests money. Whose money is this? This is your money. Your father put as a saving in a bank. The bank has given you as a loan for higher interest, and you're going to work upon it. Therefore, without a proper return revenue, you will never enter into anything. Therefore, it is not possible. So therefore, anything, even in the plant, if you try to isolate it, or animal you try to isolate it, this is a science part. After that, the working point on the drug discovery, you take the information and work upon it, right? This is called a high risk business. So funding coming for high risk business is very big problem. Nobody gives money. Every investor will think twice, thrice, 4 times, 5 times, and they say no also. So they won't give money for developing such type of thing. So who cares about it? You develop other things. There's so many things, pharmaceutical aids we call, AIDS, AIDS. Do it. So many of them. You require a technology for, a Venflon technology was developed by somebody from other country. Recently, Stryker has developed a chair. That chair is useful for patients to move from upstairs to downstairs. Ambulatory patients. When patient cannot move, they can be carried by a chair on the staircase. That is an invention. See, it's a very simple invention if you look at it. Each chair costs 4 lakh rupees. It is sold in India. Therefore, just little bit of innovation, little bit of thinking about it, identify a problem, solve the problem. You'll be able to transform.
Thank you, sir. With your detailed, no, sir, no more questions. Okay. With your detailed explanations, now we are all understand about entrepreneurship and innovation, sir. Thank you so much. And respected participants, please raise your hand for live feedback for this session now. We will unmute for you to share your valuable thoughts. Don't make any noise. Those who are interested to give a live feedback now, we will unmute for you to share your valuable thoughts.
That's interesting.
Yes, sir. With your idea, we learn this now. Wait few seconds.
Yes, yes.
Our committee members are doing the unmute work.
Oh, okay.
Please
okay.
be wait.
So when you are just talking, please identify yourself and that will be good.
Yes, sure, sir. We'll Dear Dr. T. Subramanian, sir, please unmute those the candidates who raise the hand.
It's a very good question. As a BPharm student, இதெல்லாம் தான் எனக்கு வந்து ஒரு team.
I think some
Jai Sudha. So unmute your mic, please.
few seconds.
Participants, unmute yourself.
Unmute your mic, participant yourself, you can do it. Jai Sudha B, unmute your mic and.
Hi, sir.
Yeah.
Can you hear me?
Yeah, yes.
Yeah. Unmute your video also, please. Unmute your video also.
College of Pharmacy. I'm studying in third year BPharm. So I have one question, and your speech was very motivating to me. Your speech is very motivational to me for innovations and entrepreneurship and startups. I have only one question.
Yes, yes.
What if all social media companies and AI dominates our innovations, and they patent our ideas? What will be our innovations looks? What is the future of innovation?
AI, again, I'm telling you that AI cannot take over you. It's not possible. I will not say that, AI would do everything. It's very, very partitioned, for somebody's interest, AI has been made. Somebody is having some interest. Therefore, I made an artificial intelligence to do that. For example, if an ape wanted to catch the ant from, ant hive, what it does, it takes a straw, it just puts a little saliva and enters into ant hive until. Then it takes all the ants which are stuck to that, right? And it takes and eats it. And similar principle apply in human also. Artificial intelligence, I create to know what is your liking. That's all. I can tell you, this is what it is. But human brain cannot that easily be taken over or hijacked by anybody. Innovation is a big ocean, right? Don't worry about it. But that's true. Artificial intelligence will hijack you if you allow yourself. Otherwise, it's not. Same like TikTok.
Thank you, sir.
I could see everybody in TikTok.
Participants, unmute yourself.
Dear participants, those who are interested to give a live feedback, only feedback, unmute yourself. The question and answer session was closed.
Hey, if any one of you guys want to talk in
Yes.
Tamil, I have no problem. You can talk in Tamil. I am very comfortable. You know what happened? I found is that many of our students, they're afraid to talk in English. No problem. Please talk in Tamil. I'm very happy. No problem. I can talk equally well in Tamil.
Mr. Rahul Bhattaria, sir.
Yes.
Kindly share your live feedback.
Actually, sir, very nice. Hope as a participant, all the enjoy all the webinars. So I am very, I like video and your webinar is a very giving.
Please unmute your video also.
Okay, just for a minute.
Okay, sir.
Good morning, all of us. I'm Bhavdoria from ITM University. I suggest to do as a prefer very nice, fantastic webinar because recently month I have received many seminar, but this is the mind blowing and the fabulous seminar I have just received now. Very thankful to all.
Thank you.
Thank you, sir. Thank you so much for your valuable live feedback.
Thank you, sir.
I think this is the time to complete
yes, sir.
our. Sir Bhattaria, sir, please mute your audio.
Okay.
Thank you so much. I think this is the time to complete our live feedback and question and answer sessions. Thank you for being with us, sir. Hope all participants are satisfied with your answers. Thank you, sir. Now on request, all our SSM College of Pharmacy students be live in Zoom. Our beloved speakers are going to discuss with you about the future of scope of the jobs of the pharmacy, both the B Pharm and Pharm D students. Please be wait online. Within few minutes, Dr. Velpandian sir going to discuss with you. Sir will give the valuable advice for you all and ideas to all. Dr. Velpandian sir?
Yeah, I'm here.
I think everyone are waiting for your valuable.
Oh, for me?
Yes, sir. No one not left from that Zoom. Everyone are waiting now.
Okay. See, actually, I spoke to, I think almost I explained everything. But what I wish to tell you is that, whenever you get an opportunity, one is academics, when you study, what you read for getting the minimum eligible qualification to become a professional. But everybody should have a, something which is beyond their education, so that they fit much more better into every aspects. Because now companies are looking forward for different, for example, that, those days we see only engineers getting into engineering lines. Later we found that engineers are getting into business. We never thought that, we thought that only those who are studying commerce will get into business. But engineers got into business. Now pharmacists got into business. Now MBAs are coming up, and several disciplines have a different diverse role to play. So with the one simple, degree, you come out and say that, I have done this degree, give me a job, is so foolish. So one should have a meaningful this one about it. I mean, they should have a decent degree, and they should understand what they read in their curriculum. After that, they should also try to get more information, more type of their exposure. They should increase it in other areas. Then wherever you go, you get a place. I mean, you get a some recognition, and it is very important. Scope is wide. Scope is adequate. But once somebody said that in India produce the maximum amount of engineers in the world, but 30% of them are only useful. 70% of them are not useful. But in a pharmaceutical sector, I mean, such a type of criticism did not come because probably there is a diversity in case of analysis. But by and large, what we could see at different places is that, and whatever they do, whatever they try to do in their research or try to do that, something unique is required. Otherwise, we see, I mean, there are 100 people. How do you choose one person, out of 100? You have to show yourself different from others, right? So one should develop that capability. Otherwise, you go and stand in a queue, you look for a job. That's not possible. So you should dictate your terms to get a job rather than begging for a job. This is what my advice is. So you should develop yourself accordingly, right? So that's what I wanted to say for all the students. I mean, specifically, if they have some questions, I'm very happy to answer those questions.
Thank you, sir. Thank you so much.
But all of you must give a GPAT. Ask every student to give GPAT, and without GPAT, getting into higher education is not good. So no use.
Sure, sir. Sure. Now I hand over to our respected principal, Professor Dr. B. Sangameswaran, sir, to propose vote of thanks. Thank you, sir.
Thank you very much, Nanda, my friend, Dr. Pandian. I think one more, we'll conduct one more seminar. I hope you accept it, my request. That will be organized in our institution. So it will be useful for our student to make it get together, like that get together. So I very much impressed on picture you shown, the person who is carrying his wife and his mother.
Sorry, I could not get you.
I wonder on picture which you shown, the person who is carrying his wife and I want to know
the greatest innovation.
But not only innovation, he is a god. So I want to know his address.
That's
and
so
mobile
fun,
number.
actually.
Very good. And the more thing is you are even I have an experience. Just what is ambition? He said eating. Eating is an ambition. Hello, audible. So thank you once again. Thank you very much for all the participants. So it is a wonderful seminar. Then we have received a lot of comments, good comments and everything. But I am amazing. One doctor came, Sujit Chavan. Basically, he is engineering dean, assistant professor at Institute, Maharashtra, Institute of Management. He is also participated. Not audible? It's not audible? Hello?
Audible, sir. Audible, sir.
Okay. So now, then I can just list out some participants.
Wow.
There are a lot of. Dr. Kundri Rajeshwar, that principal, Nalanda College of Pharmacy. From the beginning, he got a very good comment. So I read out that comment.
What
Especially
is this? What is this pie diagram?
The pie diagram, the who participated.
Oh,
These are the
participants.
states. Yeah, participating of various
Oh my
states.
God. Oh my God. It's beyond Tamil Nadu, right?
Yes. Just
I never thought that, it is going to be like this. Oh my God.
No, like that from Jammu, Kashmir to Kanyakumari.
Acha, okay. My goodness.
So, like that. So Dr. Kundi Rajesh,
Oh my God. I thought
principal
only Tamil
Nalanda
Nadu.
College.
Okay.
Yeah. And some more persons are from abroad also.
Oh my God. That's good. Okay. We thank all of them for joining us, right? It's good.
More than 1,000 participation were
1,000
1,000, yeah. Then live YouTube also
Okay.
from the beginning.
Right.
The principal Kundri Rajeshwari, that principal of Nalanda College of Pharmacy, we got very good comment. Actually, the principal asking your email ID and the mobile number. So those talk to you personally. The principal given good comment where expressive communication abilities very effective. That is touching my heart. Then Bhagya Lakshmi from University College of Pharmaceutical Sciences from Karimnagar.
Oh,
So
okay.
yeah.
Karimnagar, yes, okay.
So there are a lot of persons here. And then one more person inspired slide. Sir C.V. Raman and Common Man. So we see a lot of comments. Then Devara Gupta Krishna Prasad. Really great, sir.
Hey.
Beyond expectation, excellent.
I'm very happy.
And then that Kundri Rajeshwari, that Nalanda College of Pharmacy principal, he highly informative, wonderful session. Dr. Velpandin, sir, your name indicates you are blessed by God, Subramania, Muruga.
Absolutely, that is true.
So we see a lot of positive comment. I hope everybody's enjoy.
Very happy. I must thank you, Sangameswaran. I must thank you, Sangameswaran, for making it possible.
Thank you.
Thanks a lot.
I thank the faculty members who are all actively participate in the event.
They did a good job.
Yeah.
I didn't have much of a problem in awning off.
Thank you.
Thanks a lot for everybody. Thanks a lot for all your comments and wishes. Thank you. Thanks a lot.
Thank you, sir.
Bye-bye.
Thank you.
Bye-bye.
Thank you so much, sir. Thank you so much.
Thanks a lot. Fine.
Please.
Ideally, right?
If you don't mind, please wait. Some students they want to share. Our students they want to share some few words. Students of SSM College of Pharmacy.
Oh, please. Yes, go ahead. Please go ahead. Yes, please go ahead.
So don't waste your time, please to join. John Vinod?
Yes, sir.
Mute
Yes,
your video on the mic.
Your speech is most motivating to me and our college students.
Thank you.
Speak in Tamil also.
One more seminar, sir.
Sure, definitely we will.
Yes, sir. Thank you. Thank you very much, sir. Thank you very much for your time, sir.
That's all. Venkatraman sir.
Venkatraman sir.
அந்த லைன்ல வந்து
இங்கே காண போயிட்டீங்க நினைச்சேன்.
ஆஃப்டர் லஞ்ச்.
அதெல்லாம் காணாம போல. அத வச்சுக்கிட்டே தான் நடமாடிட்டு இருக்கேன். எல்லாத்தையும் பாத்துக்கிட்டே நம்மளுக்கு பேலியோ டயட் தானே, அதனால ஒண்ணும் பிரச்சனை இல்ல.
Timely diet, it's okay.
I think the students are waiting. The Soundarya.
Yes, sir. A warm good afternoon to everyone, especially Dr. Velpandian sir. Is that audible?
Yes.
Yeah. First of all, hats off to you, Dr. Velpandian sir. This is wonderful session I have ever met. We have attended more webinar sessions. Sometimes we get both, but this session is very much interesting and so innovative as the title indicates. I'm very blessed to attend your sessions. So, and one more is open forum question is mine.
Oh, okay, understood.
Yeah. So, so my request is, may I join JRF with you?
Yes, why not? You're free to apply. Do it.
Yeah, thank you so much, sir.
We'll definitely consider. Yes. We have positions available in the institute for PhD also. One can apply. Yeah, really.
Thank you, sir.
Sure.
Mohammed Sagu. Rahul.
Mohammed Sagul from Final B Farm.
Yes.
Next one.
Yes, go ahead.
Very good. Okay. Venkatraman sir வந்து டீ டைம் போயிட்டாரு. நம்ம லஞ்ச் சாப்பிடல.
பசிக்காரது இல்ல. நம்ம டைம் தாண்டிட்டு இல்ல.
1 மணி தாண்டிடுச்சு.
ஆமா.
இது சார் அது யூடியூப் லைவ் க்ளோஸ் பண்ணிடலாம்.
சார் எஸ் சார்.
Yes, please go ahead.
Session close பண்ணலாம்.
சார் லைவ் ஸ்ட்ரீமிங்கே இருக்கு சார்.